Hi, this is Dr. Cheryl McDonald of Health Psychology, and in this episode I'll be talking about health psychology and how it relates to the immune and central nervous systems. The immune system defends the body like the gladiators of Rome defended their turf, on call 24 hours a day, standing guard to resist any foreign substance that may pose a threat to physical health. When someone encounters an event that is physically or emotionally threatening, the body will respond biologically. This physical response guarantees that the body has whatever it requires to maintain balance. If people learn how the immune system operates, they can then discover ways to keep their emotions and body healthy, consequently warding off some of the physical and emotional triggers. The prevention of disease is, at least to some extent, in our control, and that is the health psychology connection. The immune system includes several organs which have billions of immune functioning cells, including the thymus gland and bone marrow that develop and mature the cells. The peripheral immune system includes the blood, lymph nodes, and spleen. The endocrine system provides hormones that aid the central nervous system by delivering the appropriate types, enabling us to survive. The true gladiators are the white blood cells that continuously wander, rummaging for foreign invaders in the blood and tissues. The white cell's purpose is to activate the immune response against the daily attacks from viruses, germs, and bacteria. Indirect invasions on physical health are environmental agents associating with anxiety, poor diet, pollution, smoking, and alcohol intake. Direct invasions on physical health are engagements with contagious environmental substances, such as viruses. A brief history of the immune system. The science that explores the organization and role of the immune system is immunology, which stems from modern medicine, even though primitive researchers also studied the causes of illness. 200 years ago, Greek experts thought diseases were produced by poisonous vapors, or miasmas, meaning pollution from decaying organic material. The earliest known reporting on immunity was written in 430 BC, during the plague of Athens while fighting in the first years of the Plebocian War. The capital was under attack by Sparta, and the residents had been relocated to live within the city walls, creating overcrowding. The poor water supply, inadequate sewer systems, and humid temperatures explain how viruses could spread conditions very swiftly. One report of the disease was from Thucydides, who recovered from plague symptoms and proceeded on to document a precise, accurate account. He wrote that people who had rallied from a bout of the illness were able to care for the sick without contracting the disease a second time. In the late 1700s, British scientist Edward Jenner had heard stories of dairymaids who contracted the disease cowpox and were by some means protected against a much more lethal illness, smallpox. Jenner studied the likelihood of transporting this protection person to person. In 1796, he extracted pus from a dairymaid's sore, applying it to the wounds of a healthy 8-year-old boy, who then, of course, fell ill. After the boy recovered, Jenner spread this time the fatal smallpox virus onto a cut, consequently discovering that the boy was immune. In 1802, Jenner was publicly mocked for this experience, as one cartoon image portrays people who were immunized sprouting cows from different parts of their bodies. However, smallpox disease is the only infectious disease that has been eradicated in this fashion, and the name given to this procedure is vaccine, from the Latin word vacca, signifying cow. For centuries, mankind invented multiple mysterious beliefs about the nature of disease, and in the 18th century, Marpupitus started trials with scorpion venom, observing that some dogs were resistant to the poison. Louis Pasteur thought that if a vaccine could be obtained for smallpox, then it should be likely to eradicate different conditions by producing a vaccine. In the 1880s, Pasteur successfully confirmed that by injecting chickens with a diluted form of the cholera bacteria stopped the animal from dying of the disease. Pasteur was in frank opposition to the miasma theory and capitalized on his view of acquired immunity in perfecting a vaccine, thereby introducing a germ theory of illness. A range of pioneering research from the mid-1800s onwards, discovered by Louis Pasteur and later Robert Koch, explained that diseases were produced by the presence of microorganisms that penetrate and then reproduce within the body. Germ theory proposed that investigators should search for microorganisms aided by following the collection of rules designed by Koch. The Latin word immunitas refers to the unique status of security or exclusion from taxes awarded to soldiers by Roman emperors, and this protection from disease today refers to this status, having the name immunity. Jenner's, Pasteur's, and Koch's discovery gave medicine the hope of preventing, healing, and treating diseases. Despite these incredible improvements, no one understood the mechanism of triggering, or in what way and for what reason immunity occurred. Ilya Mechnikov, a Russian zoologist, was a difficult, inconsistent, volatile man, although a profoundly energetic, talented researcher, capable of producing different brilliant insights. In the 1880s, while vacationing on the coast of Italy, Mechnikov was intrigued by the way simple marine animals digest and absorb nutrients. As he looked at a group of moving starfish larvae under a microscope, Mechnikov came up with the notion that these roaming cells were guarding against invaders. By taking a piece of a rose thorn and forcing it into the larva, Mechnikov observed a mob of mobile cells encirculating the thorn. Like flies flowing around and landing on meat, these cells seemed to devour and eliminate the intruding rose thorn. Mechnikov called these cells phagocytes, originating from the Greek phage, phagein, meaning to swallow, and biology suffix cyte, signifying a cell. He proposed that phagocytes were the organism's primary line of defense, and that their responsibility was to engulf and break down any foreign material. Most of us have had a cut and have seen the drainage that forms around the tissue, the dead white blood cells and other cellular rubble left behind after the phagocytes have completed their work. Koch's assistant, Paul Ehrlich, was a critic of Mechnikov, who developed techniques for staining bacteria and tissues with chemical dyes, had the idea to create drugs that specifically recognize and destroy the invading microorganisms. In 1897, he introduced a theory explaining how cells react to a variety of different threats. Ehrlich stated that cells manufacture side chains, which ultimately splinter off, travel in the bloodstream, fastening to toxic materials released by the bacteria. These side chains connect to the target in a very precise fashion, like keys match a lock, barricading the toxins from reaching their destination into the organism. Antibodies are today what Ehrlich creatively termed side chains. Convinced that only one or the other option could be right, scientists largely ignored Mechnikov's cell-based theory. As time marched on, the two theories were found to be accurate because there are two branches forming the immune system. Mechnikov's phagocyte cells do produce a first order of defense that describes innate immunity, because cells devour enemies and clean up the trash from the immune system's battles. Ehrlich's side chain, or antibiotic theory, is known as acquired immunity, a segment of the immune system's response that learns and masters how to sufficiently attack an invader. Ehrlich's views that antibodies produced a key that can identify the locks of various pathogens encouraged generations of investigators in the field. However, the fallout from this debate meant that decades passed before the broad scope of the immune system was uncovered. Ehrlich's view that side chain molecules are formed by all cells is false, because antibodies are produced by a unique type of white blood cell. In 1890, Emil von Behring injected small, weakened doses of the bacteria that produced diphtheria or tetanus into animals, discovering that they manufactured chemicals in their blood that neutralized the disease-causing poison. He also discovered that transfusing the blood carrying the antitoxin to other animals awarded them immunity from the illness. Active immunity is the defense produced by the immune system. Passive immunity is obtaining certain antitoxins from other sources. Von Behring revealed that children inoculated with the antitoxin-containing serum were cured of their diphtheria symptoms. This was a significant finding because the vaccines invented by Jenner and Pasteur prevented diseases, but von Behring's discoveries explained how a disease could be treated and cured. In 1901, the evidence to support Ehrlich's theory of antibodies won the first ever Nobel Prize in Medicine. The accomplishments of von Behring, Metchnikoff, and Ehrlich opened the gateway to creating a new era of science called immunology, and this portal attempts to investigate the hidden performances of the body's internal defense mechanisms. Once the antitoxin theory had provided credible experimental evidence for Ehrlich's explanation, investigators, researchers raced to examine these toxin-neutralizing molecules. Nearly 200 years after Jenner presented his pioneering detections with smallpox, and 100 years since the famous cell versus blood debate between Metchnikoff and Ehrlich, Doherty and Zingernagel finally earned the Nobel Prize for Physiology and Medicine in 1996. These researchers explained the mysteries of what immunologists presently described as being the cell-mediated immune defense system. Cell-mediated immunity is an immune response that does not include antibodies, but is the activation of phagocytes, antigen-specific cytotoxic T lymphocytes, and the deliverance of different cytokines in reaction to an antigen. Anaphylactic shock. The immune system provides a complex security system, but every so often this defense mechanism can act against people, creating a health crisis. Anaphylaxis, or anaphylactic shock, is the term assigned to an immediate, at times deadly allergic response, affecting the whole body to seemingly safe foods, like peanuts, and often having an association to bee stings. The Charles Ricketts study in 1900 on anaphylaxis had an unusual beginning because he was inspired while vacationing on a sea voyage. While experimenting with the toxins of sea anemones, he found that dogs that were unharmed by an initial dose of poison always went into shock and died soon after experiencing a much lower dose a few days following. He was surprised to discover that the initial dose did not increase immunities to the poison, instead making the animals highly sensitized. Charles Rickett found the biological laws pertaining to anaphylaxis relating to the Greek term ana, indicating against, and phlaxis, indicating protection. This research promoted the initiation of our medical alert systems that recognize and identify people who are susceptible to a deadly hypersensitivity. Ricketts' interpretation of how the immune system overreacts in such a damaging way awarded him the Nobel Prize in Medicine in 1913. Autoimmune diseases. The concept adopted to explain autoimmunity was coined over a century ago by Paul Ehrlich, who originally gave the emotionally disturbing label horror autotoxicus, meaning the horror of self-toxicity. No one understands precisely what causes autoimmune conditions, and the causes are likely to include a combination of factors. Researchers hope to identify techniques to subdue the overactive portions of the immune system by having a greater understanding of the biological, psychological, and sociological or environmental triggers of autoimmune disorders. In a few circumstances, the body turns on itself wrongly, producing antibodies that strike its own tissues, and this mistaken production points to developing an autoimmune disease. For example, in the pancreas, T lymphocyte cells destroy insulin-producing cells, causing type 1 diabetes, and other assaults on the body's cells lead to severe joint soreness felt by those suffering from rheumatoid arthritis. Barajou-Benesov's exploration of the immune's response genes reveals that the major histocompatibility complex performs a vital function. A larger proportion of autoimmune disease sufferers have a distinct genetic variant of this histocompatibility antigen. For example, scientists understand that many sufferers of rheumatoid arthritis have a distinct self-antigen named HLA-DR4. The Future of Immunology. The Nobel Prize in Medicine experienced an astonishing growth period for longer than a century, during which several mysteries of the immune system's functions were uncovered. The impact of this research has been extensive, and most distinctly known for the production of vaccines to prevent many conditions that protect billions of people worldwide. Today, scientists have a high level of understanding of the biological ways the body senses intrusion, which then triggers the innate immune system reaction, thus establishing antigen-specific adaptive immunity. This awareness provides priceless insights into exploring allergies, autoimmune diseases, infectious diseases, and the risk rejection that associates with organ transplantation. However, there is much that needs to be done because effective vaccines are required to tackle drug-resistant classes of pathogens that cause ailments like tuberculosis and malaria, along with preventing further threats. Scientists are exploring methods that allow patients to undergo transplanted organs and tissues without the need for the risky continuous treatment of immune suppression drugs. Investigators are also examining the ways in which the immune system is confused or defeated by cancers and viruses. The century ahead professes to be another helpful one for exploring more information about the defense mechanisms that shape the immune system, and uncovering the answers to these riddles will require further discoveries. The central nerve system's role. The brain and spinal column form the central nervous system, and all thoughts that flow through the mind, every action and emotion people experience in this world, passes through the central nervous system. The CNS can be compared to acting like a computer's motherboard, which without it the machine would not exist, because the CNS is the motherboard and control panel. We activate a computer by the push of a button that signals the motherboard to turn on the hard drive, stimulating the operating system, which transmits signals to start programs. When triggered, the central nervous system initiates a system of physical responses that interprets and communicates experiences, thoughts, feelings, and actions to the rest of the body via a network of cells, neurons, and organs. When the stimulation stops, the body needs to be restored to its primary functioning in order to maintain a healthy balance. Norepinephrine and epinephrine links to breathing, calms the sensation, and strives to restore the muscles into a relaxing state, and allows other bodily duties, such as thirst, appetite, and elimination, to resume. Without these security maneuvers, the human body could not preserve itself and would burn out, or die like a hamster that continues to race around its wheel. When the stressful state passes, more than a few people will feel exhausted due to the extra glucose administration, and this stress response typically leaves people a low measure of blood sugar, feeling as if they have not had anything to eat. The answer to combating acute stress is to advance to a state of balance, or homeostasis. The blood sugar and blood pressure will return to its customary status, as will heart activity, and alertness reverts to calm. For optimal survival, the human body does its utmost to maintain this sense of balance, implying that the goal is to remain at a uniform level of functioning. The central nervous system is accountable for overseeing the functions that allow us to survive, and directs the best reply to stressful situations by launching epinephrine or cortisol to help adjust to a threat. The CNS also regulates the production of serotonin, regulating daily functioning like hunger, sleep, and the desire for sex. Neurons, the wiring of the brain, and psychology. The average brain contains approximately 86 billion neurons, that receive communications and nerve impulses at speeds of 1/5000th of a second, and these substances that transmit the messages are neurotransmitters. It is the speed of communication on this neurological platform that empowers people to react promptly to various environmental conditions. Serotonin is commonly known as being the happiness hormone, even though it is not a hormone but a neurotransmitter contained in the spaces between the neurons or synapses of the brain. Serotonin's role in a healthy functioning central nervous system is to regulate essential functions such as sleep, sex drive, mood, and appetite. The synapses are the areas of the brain that may be interrupted when suffering from symptoms of depression. Cortisol is also present in the bloodstream, and the brain's hypothalamus governs the available quantities. A healthy hypothalamus will ensure that cortisol is present in the proper amounts and that it secretes at appropriate times to maintain homeostasis. The highest levels of this hormone are usually found between 8 a.m. and 4 p.m. Laboratory studies conducted on those who experience symptoms of depression exhibit an unusual amount of cortisol, either having it peak at odd times or levels being consistently high. A raised cortisol level over time may lead to problems associated with the metabolic, immune, and cardiovascular systems. Excess or fluctuating levels of cortisol also affect the rate at which the body produces serotonin, a mood-enhancing neurotransmitter. When people report positive mood states, there is less cortisol production compared to times when feeling gloomy. Neurotransmitters like serotonin, epinephrine, norepinephrine, endorphins, and dopamine affect mood, and consequently the way people think, feel, and behave in the world. On an emotional level, there is a segment of depressed individuals who have demonstrated low levels of serotonin, and some researchers believe that these lower levels directly link to clinical depression. Scientists are striving to determine precisely how this occurs, but low serotonin levels establish the foundation of why the medical profession prescribes most modern antidepressants. Studies reveal that almost half of depressed patients tested had unusual cortisol levels in their bloodstream. While it is inevitable that prolonged stress can give rise to bouts of depression, these conclusions suggest that there could be a physiological relationship between serotonin, cortisol levels, and depression. Approximately 19 million Americans experience depression, and this ailment affects between 10 and 25% of women and 5 and 12% of men in a lifetime. In this fast-paced modern society, symptoms of depression are as frequent as the common cold, and the research is beginning to explain how personality traits and conditions can transform nature's biology, at times having hazardous effects. The two types of stress. 1. Acute stress is an immediate response to something in the world which can be negative or positive in quality. Surgery, accidents, arguments, marriage, birth of a baby, a job promotion. 2. Chronic stress is a persistent physical response to something consistent in life and may be related to work, finances, family problems, abuse, disease, physical pain, diet, or substance abuse. The autonomic nervous system, ANS, is a section of the central nervous system containing a widespread labyrinth of nerves spreading out from the spinal cord, directly influencing all organs. It has two divisions, the sympathetic and the parasympathetic, which have opposite impacts. The sympathetic autonomic nervous system helps us cope with stressful states by launching a fight or flight response. After the threat has passed, the parasympathetic autonomic nervous system takes over, relaxing blood vessels and reducing the heart rate. The sympathetic nervous system is responsible for triggering the response directed towards the anxiety in which initiates the reaction. This means that the body decides whether it will surrender, give in to infection, or manage, fight it off. The parasympathetic nervous system is responsible for relaxing the body once the stress has been removed from the situation. When anxiety levels remain constant, the relaxation time cannot occur, and people become more vulnerable to becoming ill. In healthy people, the two divisions of the autonomic nervous system maintain balance, resulting in an action accompanied by relaxation. If stressors are continually present and people believe they are under relentless assault, the fight or flight response remains activated. The subsequent overexposure to epinephrine, cortisol, and other stress hormones can upset nearly all the body's functions, including immune system functions. If anxiety-provoking situations become chronic, a variety of stress-related signs and disorders can develop. How acute and chronic stress affects the body. Acute stress is an instant response to anxiety-provoking situations. This could imply a physical or emotional threat, such as evading a bullet, getting into a dispute with your partner, or the birth of a baby. If people are suddenly in a stressful situation, a series of reactions take place. The hypothalamus in the brain activates. Its position is above the brainstem, and the hypothalamus is responsible for connecting the central nervous system, the communicator, to the endocrine system, a collection of organs that discharge hormones via the pituitary gland. This set of reaction proceeds along the sympathetic nervous system, relaying the message to get moving. This part of the nervous system manages the fight or flight response and is the body's method of maintaining balance when under acute stress. When someone is shouting, people will either fight back or escape into a safer place. The physical consequences of acute stress vary from an increased heartbeat to shallow breathing and enhanced awareness because of the higher stream of oxygen flowing into the brain and body. These reactions occur because of a discharge of adrenaline, which is the chief stress hormone, and there is also a release of cortisol, another stress hormone delivered by the adrenal gland that increases blood pressure and blood sugar. The liver also starts to manufacture glucose and provides extra energy. Scientists are stating that being better prepared points to being less distressed, and that being less distressed will generate less production of daily cortisol. The health psychology relationship is that people can discover ways to become more organized, which leads to a reduction in anxiety and lowered production of the physically damaging cortisol. Inflammation is the primary cause of all chronic degenerative diseases, such as arthritis, allergies, asthma, diabetes, lupus, heart disease, chronic fatigue, fibromyalgia, and a host of others. Inflammation causes a strong response from the immune system to pathogens that cause injury and physical illness. When the stress response does not turn off or relax, the immune system is overloaded and is in a weakened, compromised state, causing people to become susceptible to contracting a physical illness. Causes of chronic inflammation. 1. Toxins, pollution, pesticides, food poisoning. 2. High levels of insulin in the blood, diabetes. 3. Infection, skin conditions, poor healing. 4. Oxygen-free radicals, cell death, aging. 5. Allergens, pollen. 6. Lack of exercise. 7. Chronic stress. 8. Medications. 9. Insomnia. 10. Diet. The cortisol connection. As introduced, both cortisol and adrenaline are hormones that are manufactured by the adrenal glands on top of the kidneys. When people come in contact with an acute stress situation, the adrenal glands will respond by producing adrenaline. If people are exposed to prolonged stress, the body will respond by producing a different hormone called cortisol, which is regulated by the hypothalamus in the brain. This physical reaction comes about because of the desire to maintain a sense of balance. When exposed to chronic stress, the physical body will react by releasing cortisol in preparation for the fight or flight situation. Cortisol effectively mobilizes the body on every functioning level to ensure it has sufficient incentive to survive the danger. When someone has chronic stress, cortisol's role is to improve the ability to maintain balance by releasing this hormone in hopes of achieving 1. Immediate energy and strength to endure, 2. A reduction or a desensitization to pain, 3. Improvement in memory function. These chemical processes and the release of hormones for survival are normal. However, high levels for long periods of time are dangerous to psychological and physical health. Therefore, these protective responses can be extremely hazardous. When stress hormones circulate in the bloodstream for prolonged periods of time, they can cause physical conditions including blood clots, angina, and heart disease. In response to chronic stress, the increase in cortisol produces the following physical effects. 1. Slows down digestion, which relates to weight loss and weight gain. 2. Increases the blood sugar level, which is a direct link to diabetes. 3. Metabolizes protein, fats, and carbohydrates by converting them into glucose and increasing the probability of becoming diabetic. 4. Reduces the inflammatory response and may increase susceptibility to physical irritations and infections. 5. Depresses the immune system by deactivating white blood cells, decreasing the ability to fight off infections, viruses, and bacteria. 6. Increases blood pressure, causing a strain on the heart. Common conditions linked to the immune system that may be reversed. Anxiety. The brain, the mind, and the body are inseparable, and communication between them can create physical changes. The brain notices a stressor, and then a physical response triggers emotional effects that can produce mental and physical harm. A few problems, such as muscle tension and headaches, are oftentimes directly induced by the physical responses that follow anxiety. Pain. Stress complicates underlying painful ailments such as fibromyalgia, lupus, herniated disc, chronic pain syndromes, and repetitive strain injuries. Migraine patients say that stress contributes to headaches, which can last for days. Neck, shoulder, and backaches are remarkably widespread due to poor posture and inactive lifestyles. Continued stimulation of nerve tissue through prolonged stress can point to muscle spasms, such as backaches. Type 2 diabetes. There is some indication that persistent stress may affect diabetes, especially in people who have the genetic predisposition. The National Academy's Press states that it is possible that stress provokes the immune system to suppress insulin-producing cells. Infertility. People who are attempting to become pregnant are more likely to conceive during celebrations or when facing little stress, and fertility therapy is more successful during these times. There is a general association that anxiety interferes with pregnancy, and that psychosocial worry contributes to the causes of some types of infertility. High blood pressure. Identified as hypertension, this is a somewhat common chronic condition that ordinarily has no noticeable signs. Nevertheless, hypertension increases someone's chances of acquiring heart disease, kidney failure, and stroke. Anxiety elevates blood pressure, and chronic stress may contribute to an enduringly inflated blood pressure. If there is a family recorded history of hypertension and heart problems, people should have routine checkups with their physician and follow the advice. Dermatology problems. Stress can intensify skin conditions such as eczema, psoriasis, and acne, and likewise has a relationship to unexplained itchy skin diseases. These dermatology difficulties are themselves profoundly anxiety-provoking. Vulnerability to infection. When people are under stress, the immune system is suppressed, making them more vulnerable to infections. Allergies and autoimmune diseases, including fibromyalgia, arthritis, lupus, and multiple sclerosis, may be intensified by anxiety. Emotional tension also slows the pace at which people recuperate from any ailment. Stress can be partly balanced by social support from family and friends. Chronic conditions that are linked to a weakened immune system. Arthritis, insomnia, allergies, infections, depression. inflammation, persistent pain, digestive disorders, poor wound healing, chronic fatigue and fibromyalgia, asthma and other respiratory disorders, chronic fever, diarrhea, swollen lymph glands, 2 or more colds or flu a year with slow recovery. How to achieve health and prevent illness. All living organisms strive to maintain balance or homeostasis, which is routinely challenged by internal or external triggers. Stressors are triggers which are physically harmful, and these triggers are emotional, physical, and or environmental. Stress threatens stability or homeostasis, and the ability to reestablish balance, which can be accomplished through behavioral and physiological responses that attack the intruders, the viruses or bacteria. The magnitude and chronicity of the stressor is crucial in understanding, because when any trigger exceeds a certain severity, it activates the central nervous system's adaptive response. In other words, a little anxiety in life that is short-lived, forgetting where you place your car keys, is much less physically and emotionally damaging than facing a housing foreclosure. The challenge is learning techniques or ways to cope with life's problems, thereby decreasing the biological response. Anxiety reduction. Stress produces a biochemical reaction, and the overproduction of cortisol and adrenaline lowers the immune system's ability to fight off physical illness. This process explains why the common cold virus may take hold during difficult times, because the weakened immune system simply does not have the strength to fight off infection. Find ways to reduce stress. Listen to music, go for a walk, practice relaxation techniques, or find someone to talk to about the anxiety to discover a personal way to reduce the tension. Learn to become organized. Studies show that being organized decreases anxiety levels and reduces high cortisol level that decrease the immune system's ability to fight off infection. Take the time to plan the day. Physical exercise. Regular, gentle exercise, like walking, helps promote the immune system by encouraging the organic killer cells eliminate bacteria and viruses in their tracks. People become less physically active with age. Therefore, those over the age of 55 may benefit the most from physical exercise. A walk refreshes the immune system by reducing anxiety and encourages and assists the antioxidants that protect us from disease. Get adequate sleep. The body needs rest to remain in balance. Sometimes sleep is the best medicine, especially when trying to fight off a cold or the flu. Learn a relaxation method. Develop a routine to prepare yourself to calm down, which produces a restful night's sleep. This wind-down time should be at least 1 hour. Hand washing. A powerful and basic behavior that fights germs. Use soap and water and wash for 15 to 20 seconds. During flu season, avoid hugs and physical contact with associates, friends, and co-workers to prevent the spread of germs. Maintain a healthy diet. Foods that are eaten have a direct influence on the immune system, because deficiencies can impair the ability to fight off infection. All fats weaken the immune system because they confuse white blood cells and impair recognition of foreign foes. Tissue and organs decay through oxidation, thereby causing common diseases, and the antioxidants strengthen the organ cells, assisting with stability by slowing down the oxidation process. The solution is straightforward. Eat more fruits, vegetables, oats, grains, legumes, nuts, berries, and mushrooms. Buy some organic produce to reduce pesticide consumption. The micronutrients are higher and pesticide levels are less in organic foods, under most circumstances. If fast food is a must, choose healthy fast food menu items and pay attention to calorie intake, along with consuming less sugar, salt, and fat. Everyone can consciously choose to live a less stressful life, and this is the good news, because people are in charge of understanding that there are choices and make these decisions. Changes in habits and routines can be accomplished whenever there is a genuine desire to live a healthy, productive life. The goal is to build on that healthy lifestyle from one day to many days, then to months, and ultimately to your lifetime. This is Dr. Cheryl McDonald of Health Psychology, and thank you for listening to how health psychology relates to the immune and central nervous system.